Have you ever wondered why Earth doesn't have rings? Gas giants, Jupiter, Saturn, Uranus, and Neptune, have them. But the rocky planets, Mercury, Venus, Earth, and Mars, don't. Two theories describe how ring systems potentially developed. The first one says that rings may have formed from leftovers that date from the time a certain planet was forming. Or, as the second one says, they could be the remains of a moon that was either destroyed in a collision or broken apart by the gravitational pull of its parent planet. Scientists still don't know why the gas giants have rings, but they think it could be because they formed in the outer solar system. Rocky planets formed in the inner area of our solar system, which is why they were more protected from potential impacts and collisions that might have formed rings around them. Or the reason is that the bigger planets have a larger volume, which allows a ring system to remain stable. Some scientists think our planet did have a ring system a long time ago. In its early stage, a Mars-sized object hit the Earth, and this probably resulted in a dense ring of debris. But its ring system pretty soon coalesced, and that's the way our moon was formed. More than 10 years ago, in 2011, astronomers found a huge water vapor cloud about 12 billion light-years away from our planet. This cloud is the oldest source of water that we know of. It dates back to when the universe was only 1.6 billion years old, and now it's 13.8 billion years old. This unusual cloud is also the biggest source of water that we know of. It holds 140 trillion times the amount of water that the Earth contains in all its oceans. Enormous. The cool thing is, this vapor cloud is kind of feeding a black hole. It may contain enough gases, such as carbon monoxide, to help its black hole grow even 6 times bigger than it is now. We all know that Earth has one moon, but there are 2 more asteroids, 3753 Carina and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one, 2002 AA29, follows a horseshoe orbit around our planet. Its specific path brings the asteroid closer to us every 95 years. You'd expect Neptune to be an extremely cold and dark place. After all, it's an ice giant 2.8 billion miles away from the Sun. There's not too much sunlight there, so noon on Neptune is similar to twilight on our planet. But this ice giant appears to be creating its own heat. To be precise, 2.6 times more heat than it gets from the Sun. This probably has to do with all the pressure near the planet's core. It builds and releases hydrogen, which keeps Neptune's center at a crazy temperature of 9,300 degrees Fahrenheit. But its atmosphere is still quite chilly. It ranges from about -240 degrees Fahrenheit to -330 degrees Fahrenheit. What shape do you think of when someone mentions storms? Probably long ovals of hurricanes and conical tornadoes. But that's something we see on Earth. At Saturn's North Pole, a storm has been raging for at least the past 40 years, and it has a hexagonal shape. Such a weird shape probably has something to do with Saturn's turbulent gas, or maybe even with zonal jets that extend many miles down into a region of extremely high pressure. Have you ever wondered why planets don't twinkle while stars do? The thing is, if you were out there in space, you wouldn't see them twinkling at all. The reason we see stars twinkling is because of Earth's atmosphere. The pin-sized light coming from a star hits the atmosphere. The atmosphere then refracts it, which sends the light skittering off in a zigzag. That's what we perceive as the twinkle. Planets appear much bigger to us than just pinpoints. And yes, their light zigs and zags after hitting the atmosphere too. But those motions cancel each other out, which is why we don't see twinkling, but only a steady glow. In some regions, you can expect big changes in temperature. For example, in Montana, where in a single day, temperatures went from -54 degrees Fahrenheit to 45 degrees Fahrenheit. Yeah, sounds like a lot, but it's still nothing compared to Mercury, where temperatures tend to vary over 1,000 degrees Fahrenheit in a single day. They start out at -280 degrees Fahrenheit at night, and eventually go up to 800 degrees Fahrenheit during the daytime. Picture a wardrobe you'd need to prepare for a single 24-hour visit to Mercury. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. When you think of volcanoes, you probably picture hot molten lava coming out of them. At least, that's how it works on Earth. But in space, volcanoes can spew methane, water, or even ammonia. Up there, a volcano can also spew specific materials that freeze as they erupt. Then they turn into frozen vapor and some sort of volcanic snow. It's a common thing on Jupiter's moons Europa and Io, also on Pluto and Saturn's moon Titan. They're called cryovolcanoes, and Io has extremely active ones. Over there, you'd see hundreds of vents with plumes of frozen vapor that tend to extend about 250 miles. And NASA vehicles have even captured some erupting in real time. Bam! Planets, moons, asteroids, comets, and stars, they can all collide. And galaxies too. Our galaxy, the Milky Way, is 2.5 million light-years away from Andromeda, our closest galactic neighbor. Astronomers believe the Milky Way is on a collision course that will destroy both galaxies in the distant future. Or at least, galaxies as we know them. The two galaxies are going faster and faster toward each other at a rapid clip, 250,000 miles per hour. It will be chaotic, and many planets and stars won't survive the collision. Eventually, these two massive entities will merge and turn into a completely new, unrecognizable galaxy. But here's a small comfort. Scientists assume this is not scheduled to happen for another 4 billion years. In case you want to fuse two pieces of metal together, you already know the only way to do that is to apply heat so these pieces can reach their melting points. In space, you don't need heat to do such a thing, or basically, any action at all. We call it cold welding, and such a phenomenon happens when you slide the metal pieces over each other. In that case, they wear away their protective oxide layers. On Earth, these layers stop them from fusing, but in space, this type of protection disappears. That's why the electrons from one piece of metal just flow into the other piece. And ta-da! They're one without any effort. Scientists used to believe the Earth was the only planet in our solar system with tectonic activity going on. Tectonically active means plates under the crust are moving. This process releases heat, which then deforms the Earth's surface and leads to its shrinking. But now, we know this happens on other planets too. Mercury is also shrinking, and scientists found it out in 2016 when the Messenger spacecraft orbited the planet and sent back some important data. It revealed that there were cliff-like landforms known as fault scarps on Mercury's surface. Since these landforms are relatively small, they probably didn't form that long ago. That means Mercury is still contracting, even 4.5 billion years after our solar system was formed. Jupiter's Great Red Spot is shrinking as well. It's a huge storm that rages on the planet's surface. It's reddish, a bit oval in shape, and more than 10,000 miles wide. Yep, that's big enough to swallow the Earth. And now, it's been slowly but surely shrinking for a couple of centuries. The Great Red Spot is just one of many high-pressure storms that occur across Jupiter due to all those gases present there, which is something that classifies Jupiter as a gas giant. But just because it's shrinking doesn't mean the Great Red Spot is going to blow itself out anytime soon. It's even growing taller. The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around -400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days. Our sun is insanely massive. Want some proof? Well, 99.86% of all of the mass of the solar system is in the mass of the sun, in particular, hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks that threaten to damage their spacecraft. Sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that a chance of collision is next to nothing. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that has been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. While looking up at the stars through your kitchen window, you ask yourself, could you send pizza to space? And more importantly, could you still eat it if it came back? These are some mighty important questions. Okay, focus. How are we going to send the pizza to space? Given that NASA's first space shuttle cost roughly $49 billion, I don't think they'll allow us to borrow a rocket ship for the day, since they may have, more important things to do. Without our rocket ship, we won't be able to get the pizza that high, or to travel at that speed. Okay, fine, they can keep their rocket. I'm happy with my amazing weather balloon, which, by the way, will still get us 1/3 of the way to space, bringing us to the area known as the edge of space. Given that the atmosphere up there is so thin, about 1% of the pressure at ground level, it's really not that bad of a substitute for actual space for this test. I was never comfortable with being that far away from my dinner anyway, so this works much better for my food abandonment issues. To ensure we could find the pizza once it landed, we attached radio trackers to it before launching. These send a signal with a GPS position to the ground, which is then put on a map for us to chase, giving us a good idea of where the pizza will be found. Oh man, I love technology! And just like that, the moment has arrived. We found our pizza intact. And after some moments of passionate hugging and loving strokes, I'm ready to take a bite. So, was the wait worth it? How does it taste? And can you eat it? Yes, you can. But the taste? Not that great actually. And despite mentioning it earlier, I forgot to bring my microwave. The crust's been frozen from the frightening temperatures experienced on its journey. And I actually mean frozen. The bread itself has an icy middle. But before we can even discover this, we'll notice that when we go to rip a piece of the pizza off, it doesn't tear as normal. Instead, it snaps off, as if we've just broken a piece off a twig. We can even hear a clicking noise. My warm, soft bread is no more. You'd be better off keeping this for dessert, in the event you run out of frozen ice cream. On second thought, let's just throw it in the trash. Nonetheless, it's pretty cool that we were able to send this garlic bread to the edge of space and still end up eating it, right? We all know the Earth has one moon. But there are 2 more asteroids, 3753 Cruithne and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it's looking like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one follows a horseshoe orbit around our planet. Its specific path brings this asteroid closer to us every 95 years. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. A recent study claims that the Moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the Moon's surface and further into space. For several days each month, the Moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Turns out, there are plenty of planets in the universe and even in the Milky Way galaxy that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface, there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Mars quake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Mars quakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight, they're gonna let it all hang out. Or something. Our moon could be hiding way more pockets of water than scientists used to think. Its surface has something called cold traps. Those are areas that are in permanent shadow. If you could stand near one of the moon's poles, especially the South Pole, you'd see such shadows all over the place. There are tiny cold traps, and there are hundreds and thousands of bigger ones. These regions are in eternal darkness, and might have even gone without the slightest ray of sunlight for billions of years. And now, scientists think they're hiding much more than we thought, including small patches of ice, no bigger than a penny, but still, something astronauts could use to drink or for their rocket fuel. The majority of the water could be stored in glass or somewhere between grains on the surface of the moon. One theory says a huge part of the lunar surface could have the capacity to store water, but no one can prove it until someone goes there in person or sends rovers that would dig under the surface. The moon is not entirely white and devoid of color. Apollo astronauts that landed there in 1969 said the moon was a bit brownish. Later studies showed some dark lunar areas display hints of brown and blue.